Good morning.
Good morning.
How's everyone feeling today?
Great. How are you?
Good. Kind of feels like Friday.
Yep.
It's not, but anyway. All right, so let's see who's here first of all. Let's see. So, okay, so no class on Tuesday, snow day. All right. Are we missing anybody in Holbrook? Looks like we're missing several.
Yeah.
Desiree,
Desiree,
Maddie, Madison,
Madison,
Tara.
Tara.
That's it, right?
Did she say
She's saying.
Who else?
That's it.
Okay, so just the three. All right, and let's see. It looks like we're missing Avery. Oh, there he is. Okay, so a couple of things. So today we're going to finish 6-5, and that's what we're going to have a quiz on Monday. So on this material that we cover today, you'll have the weekend to review your notes or practice problems or whatever. So Monday we are not going to have a broadcast. It's President's Day. MPC is in session, but to help accommodate your schedule, we're not going to have a broadcast, but instead you're going to have the quiz on this material that we finish up today, at least from 6-5. Then the Chapter 6 test will be next Wednesday. Okay? Now, my question to you is, when do you want the quiz open on Monday? Do you want it during class time? Do you want me to open it up for a longer time?
Can you turn on the microphone? Could you open it up for a longer time?
What would you tell me? What would work for you?
In the morning, like early.
So like from 8 to noon?
Yes, please.
Yeah.
All right. Is that good with everyone?
Yeah.
Yes.
All right. So I'll have it open from 8 to noon, and you need to do both attempts. Okay. Some of you actually finished the first quiz, both attempts within 10 minutes yesterday. So that's good. That's good, as long as, if you're getting good grades. Because there was like a little glitch on the opening of the quiz, and I just finished fixing it, and within like less than a minute I got a text from Holbrook and an email from Joseph City letting me know. So anyway, that's how I know you were already for the second quiz. So that's great.
Mr. Strong,
Yes.
so on Monday, is it only gonna be the 6.5 quiz open?
Correct. Only 6-5, and so I'm sure that it will take you less than a half hour to do both attempts.
So
For sure.
I didn't finish my second attempt yesterday, so if I email you to open it, would that be fine?
Your second attempt on
6.4.
6-4. Yeah, please email me, and I could. Probably what I'm going to do on that is I'll just wait until Wednesday, because normally what I'm trying to do this semester is have the proctored quizzes, and so we're doing those on Monday. On Wednesdays. So I'm making an exception for this quiz on Monday, but the fact that I'm doing it across the board makes it, I'm trying to make it equitable. So I guess what I'm saying is I really don't want to open up a quiz for you to take it home on Monday that everybody else had to take under proctored conditions. Does that make sense?
Yeah.
So I'm probably not going to do that, but if you you know, if you have some extra time next Wednesday, or if you work out another time with Miss Smith, actually on tomorrow even, if you'll send me an email right away, I could open up something if it's okay with Mrs. Smith for you to take it tomorrow. Okay?
Thank you.
All right. Any other concerns? Okay, so I'm going to write this down. So for Monday, you don't have to come to school for me, but you do have to take that quiz. But you can take it at home from 8 to 12 is when it'll be open. So that will be 6.5 quiz. Okay, and then like I said, the plan is for us to take our first test, Chapter 6 test, next Wednesday. Okay. All right. So any other concerns here before we get started? All right. Well, let's do it. Okay. Let's find out where we were. Oops. Okay, here we go. So we're on practice 2C. So if you want to find that on your guided notes, let me share that. Okay. Okay. Okay, so I'd asked you to do this before class today, so hopefully you worked through it. Let's go ahead and go over it though, in case you didn't. So it says find the exact value of the cosine of the arctangent of -3/4. All right, so the first step here, oh, let's see, for some reason the self view is off and I can't tell if you guys can see me or not, but okay. Can you see me now? Okay, great. Okay, so the first step is to draw a triangle that has a tangent of -3/4. So the fact that it's negative means we want to be in quadrant 4, because the arctangent is only defined in quadrant 1 and 4, and it's positive in quadrant 1, so we want to be in quadrant 4. Okay, so we draw the angle coming down from the x-axis, and I just label the angle theta, or you can label it x or whatever you want, and then opposite over adjacent would be -3/4. So the y value is negative because it's going down. Okay, and then how did I get the 5 there?
The Pythagorean theorem.
Pythagorean theorem, or you might even just know that it's a 3-4-5 triangle. Okay, so because a 3-4-5 triangle, that's a Pythagorean triple. So you get 5 from that. So that's your triangle right here. So now you want the cosine of that. So then the cosine of this angle adjacent over hypotenuse would be 4/5. And so that's the final answer. Okay? All right. Any questions on that? Okay. How many of you got that right? Worked that before? Okay. Excellent. Okay. All right. Okay, so next says the first step of many trig application problems is to determine a trig function in terms of the other quantities. Okay, so just like when we did these before, when we did trig applications before, you need to know which trig function you're using. Okay, so in this example, we're asked to find the angle. Okay, and so here, so like this distance is 200 yards, this distance is 500 yards. We want to know what that angle is. So then you ask yourself, in relation to that angle, which trig function relates these two sides that you know?
Sine.
Sine.
Sine, because sine is opposite over hypotenuse. So then you write the equation, the sine of theta is equal to 200 over 500, opposite over hypotenuse, and then you can reduce that fraction to 2/5. So then to get the angle, you use the inverse sine key. So, you take the inverse sine of each side. So the sine of the inverse sine of the sine of theta, that's just going to give you a theta. So that's what we want. And then to do the inverse sine of 2/5, see, that's not on the unit circle. Okay? So that's not on the special triangle. So normally when we're doing an application problem, we're going to be using the calculators for these. Okay? So let's grab the calculator. Okay, so we want the inverse sine of 2/5. Now, here's the deal, is the inverse trig functions give us the angle, right? So we're asked to find the angle. Now, typically in real life, in the real world, if I ask, well, what's the angle that, that ramp makes or whatever, or if I'm trying to build something, you don't usually give the answer in radians, okay? So normally for these application problems, we want to be in degree mode, okay? So we're going to look and make sure we're in degree mode. Okay, so we need to change it to degree mode because that way we want our answer to be in degrees. All right, so now we do the inverse sine. So that's second sine is the inverse sine of 2/5. And then the answer would be 23.578 degrees. Okay. All right, any questions on that? All right, so go ahead and try practice 3A on your sheet. All right, so Kinsley, when you've got it.
I got 33.69 degrees.
Okay, 33.69 degrees. Let's see. Very good. All right, any questions on that? Anyone like me to go through it? All right, so great job, Kinsley.
Mr. Strong, can you go through it?
Yeah, sure. Okay, so it says a student walked 30 feet from a classroom building 20 feet tall. Find the formula to find the angle of elevation to the top of the building. So if this is the building, it's 20 feet tall. The student walked 30 feet from the building and then is measuring the angle up. That's the angle of elevation. So then you say, what trig function relates this side that you know and this opposite side here? So that's adjacent. Opposite over adjacent is tangent. So the tangent of theta is 20 divided by 30, which simplifies to 2/3. So then you do the inverse tangent of both sides. So the inverse tangent of the tangent just goes to theta. And so then you just do the inverse tangent of 2/3, which would be 33.690 degrees. Okay, is that all right? Okay. Okay, now in calculus, sometimes we have to write trig functions as algebraic expressions in X. Okay, so let me explain what this means. Is so like the last one, we want to find maybe the tangent of the arc sine or something like that. But now notice that instead of like over 3/4, we have an x in there. Okay, so there's going to be x's in our answer. But really we do it the same way that we did the triangle one that we started with. Okay, where we draw the triangle. So you start off drawing a triangle that has a sine of x over 4. Now, the thing here is we don't really know what quadrant it's in, okay? So usually you can just draw it in the first quadrant, okay? All right. So here's my triangle. Well, actually, I just did a triangle. So it really doesn't matter what quadrant it's in because you don't know what x is anyway. So you say the sine is x over 4. So that would be opposite over hypotenuse. So then you use the Pythagorean theorem to get the third side. So the sine is x over 4, opposite over hypotenuse, and then you use the Pythagorean theorem to write the hypotenuse in terms of x. So in this case, the other side, a squared plus x squared equals 4 squared. A squared is 16 minus x squared. A is the square root of 16 minus x squared. So then once you get the third side in terms of x, now your answer is the tangent of that angle, which is opposite over adjacent. So the answer is going to be x over the radical 16 minus x squared.
Would you have to rationalize that?
No. Okay? Yeah, I don't like rationalizing stuff anyway, and I like that answer just fine. All right, so why don't you go ahead and try practice 3B. All right, Ricky, when you've got it.
I have no idea what I'm doing.
Okay, so the first thing you do is draw a triangle, okay? Now, you want the tangent of the triangle to be 2x, okay? So that's opposite over adjacent. So from whatever angle you call theta or x or whatever, your unknown angle, okay, have the opposite side, label it 2x. And what will the adjacent side be?
What?
1. Okay? So 2x over 1. All right, now you've got to find the third side of the triangle. Okay? So you've got the tangent is 2x over 1. So now to find the third side of the triangle, you're going to use the Pythagorean theorem and just write it in terms of x. You're not going to be able to solve it. You're not going to know the number. You're just going to put it in terms of x. So using the Pythagorean theorem, you get 2x squared plus 1 squared equals c squared. And so then to solve that for c, you square everything out, take the square root. So c is the square root of 4x squared plus 1. All right, so everybody cool with that?
I have one question.
Okay.
Doesn't 4x squared plus 1 reduce? Like the square root of it? Can't you put that down to 2x plus 1?
That is an excellent question. I actually expected that on the example, but so let me explain it here. On this is what we had on the example. See, the thing is that this does factor, but the difference of two squares factors to conjugate pairs. So it's not a perfect square. Okay? It's like, okay, so if I did, well, let's see, if I did, okay. So if I did the square root of 3 squared plus 4 squared, okay, what would that be? Okay, now wait, I don't want you thinking about it too much. Okay, if it worked out what you were saying, if you could actually do the square root of this, then maybe it would be 3 plus 4, which would be 7, right? I mean, if your theory holds up. But see, the problem is that this is 3 squared is 9, 4 squared is 16. That's the square root of 25, which is 5. And 5 is not equal to 7.
Oh, I see.
So you cannot take the square root of a sum. Now, what you can do is if I had the square root of 3 squared times 4 squared, then I could bring that out and say I could bring out the 3 and the 4, and so my answer would be 12. So when it's times, you can do those because they're perfect square factors. But when you have a plus in the middle, you can't. Okay?
Okay, got it, thanks.
So I appreciate you asking that question because every semester I have students making that same mistake. Okay, so this does not simplify. Okay, so it's just the square root of 4x squared plus 1. Okay, so then Ricky, what is the final answer then here?
It's what?
It's what?
So that
You got to say it again.
I don't know.
Okay, so let's go back then. So the secant is the reciprocal of what trig function? The secant is the reciprocal of what?
Cosine.
Cosine. So what's the cosine of theta here? In terms of x?
Adjacent over hypotenuse.
Okay, so then what would it be with these numbers that we have?
1 over square root of 4x squared plus 1.
Great. So that's the cosine. So then the secant, you just flip that. So it would be the radical over 1, or just the radical, square root of 4x squared plus 1. Okay? Does that make sense? So you find the cosine and then flip it. So the answer is radical 4x squared plus 1. Okay? All right. Any other questions on that one? All right. All right. So the last part, calculator and the inverse trig functions. So to approximate values of the inverse trig functions, you use the second key and then sine, cosine, or tangent to get the inverse trig functions. Really, the only caution I have for you on these problems is to make sure you're in the right mode. What's the right mode? The mode is whatever you want it to be. So if you want your answer in angles, in degrees, be in degree mode. If you want your answer in radians, be in radian mode. Okay? So now just kind of look at these just for a minute before you start jumping in on your calculator. So the arctangent, remember that's the same thing as inverse tangent. So you do second tangent and then negative 8.45. And if you're in degree mode, then it's going to give you a negative angle. And that's okay. That's the angle in quadrant 4. So that's okay. All right? Inverse sine. So you do second sine, 0.2447, press enter, and it gives you the answer. And again, it's in degrees. I'm in degree mode here. Okay, now, the arc cosine of 2, when you plug that in, you do second cosine of 2, and anyone want to guess what you're going to get there? Well, you actually get
An error.
an error message. Because remember, cosine is only defined from -1 to 1. So the inverse cosine, you have to plug in a number between those values for sine and cosine. So when you get an error message, that's probably what's going on. Okay? So there is no angle that has a cosine of 2. So it's undefined. All right, so go ahead and try those 2 practice problems there. All right, so Sari, when you got the first one?
I got 31.788.
Okay. So 31.788. Make sure you put degrees if your answer is in degrees, because if you leave it off the little degree symbol, it's assumed to be radians. And so then that would be wrong. Okay. All right, and the second one. All right, Hannah.
Error.
Yep. So it's undefined. So you get an error message because once again, cosine and sine, the number has to be between -1 and 1. Okay? All right. So any questions on that? Or anything in this section? This is on 6.5. We're actually done with 6.5 and done with chapter 6. Any questions? Okay, so so we're gonna have a quiz. The quiz on 6.5 will be Monday from 8 to 12. All right, now in chapter 7, I just sent the guided notes this morning. But in chapter 7, a lot of what we're going to do, and if you happen to look at the very first page of guided notes when you get them, there's a lot of formulas, okay? So what I'm going to ask you to do is either going through your book or in the back flap of your book, let's see, is it the front or the back? Yeah, the back flap of the book, there's a lot of formulas. What I want you to do when you get those guided notes for chapter 7, we're going to go through each set of formulas and learn how to use them. But I don't want to spend class time having you write down formulas. That just drives me crazy. So I'm going to ask you to do that before we meet on Tuesday. Okay? So you're going to go through those guided notes and just write down the formulas and be ready, okay? Everybody good with that? And if you've got them now, you can get a head start because I'm quitting early today to give you time to do whatever you need to do. So if you want to start on the formulas or start studying for a quiz or the test or whatever you need to do. All right? So any questions?
Thank you, Mr. Strong.
You bet. You guys have a great weekend, and I will see you on Tuesday. Okay? Don't forget the quiz. Write it in your planner. Okay? All right. All right. Love you too. We'll see you.
If the teacher
Hey, good job, Andres. You're doing great.